Hosted services were introduced in ASP.NET Core 3.1 and are an excellent way of running background tasks. They can be used in an ASP.NET Core web application, which is ideal if we want to run a background task that will affect all users. In this video, we're going to have a look at running an ASP.NET Core background task using hosted services. Come the end of this video, you'll learn how to create and configure a hosted service. In addition, you'll see the hosted services relationship with dependency injection. Now for more ASP.NET Core tutorials, visit roundthecode.com, subscribe to our YouTube channel at youtube.com/roundthecode, and follow us on LinkedIn at roundthecode.com/LinkedIn. There are a couple of ways of how we can create a hosted service. First way we can do it is to inherit the iHosted service interface. Within that, we must implement the start async and stop async methods into our class. We can then kick off our background tasks in the start async method. However, one thing to note is that we would have to fire off our tasks as separate tasks using task.run. Otherwise, the web application will never start. The alternative is to inherit the background service class. The background service class is an abstract class that also inherits the iHosted service interface. One of the benefits of inheriting this service is that we don't have to implement the start async or stop async methods. However, if we wish to override them, we can do that. In the background service class, there is an abstract method called executeAsync that allows us to execute a task. As it's an abstract method, we have to override it into our background service. And unlike running a task in start async, we don't have to run a separate task and risk the application not starting. We can make the execute async task asynchronous by using the async modifier and run our task within it. Let's take a look at these in action. So we've got a background service here that inherits the iHosted service interface. Within that, it requires two methods, the start async and the stop async methods. If we look at the iHosted service interface, we can see that we need those methods to be implemented into any class that it inherits. If we go to the My Background service, this inherits the background service abstract class. Within that, there's an abstract method called executeAsync. And if we have a look at that, we can see there that it's abstract. So there are the two different types of background services that you can use. When configuring services, there is an extension method called addHostedService in the iService collection interface. As the addHostedService extension method is expecting a class that inherits iHostedService, we don't specify the interface when adding the hosted service. If the web application has a startup.cs file, which will always be the case if using .NET 5 or lower, it can be added using the iService collection type parameter that is passed into the configure services method. If the web application is used in .NET 6 and was created using the .NET 6 template, then we can add it into the program.cs file. Let's see how we can add it to a .NET 6 application. So we've got our program class open in our ASP.NET Core 6 MVC application. And what we want to do now is we want to add the hosted services to the iService collection. So what we do is we call builder.addServices and we call this extension method called addHostedService. We're going to pass in the background service for the first one, and for the second one we're going to do exactly the same, but we're going to pass in the myHosted service. Let's run the application now. You can see our application is running, and if we bring in the console application, we can also see that our background services are running. Going into the background service, you can see we're looping it in a stopping token whilst the cancellation is not requested. What it's doing is it's outputting the current time and then delaying the task by a minute. We're doing exactly the same with the myHosted service inside the start async method, but you've noticed we've wrapped it around the task.run method. The reason why we've done that is because if we were to do it in the start async, the web application relies on this to be completed before it actually starts the application. We're going to go ahead and take that out of there and put it in like that. What we'll find, if we just make some amendments here, we need to make it asynchronous. We don't need that. What we'll find now is if we start the application, the actual web application will never start. So if we try to run the web application now, you can see it's hanging and it's come back with a site cannot be reached because the web application hasn't been launched. How dependency injection works. Hosted services are added to the DI container using the singleton service lifetime. As a result, it can only resolve singleton and transient service lifetime classes that are injected into it. If we were to inject a scope service lifetime class into the hosted service, it would not know which scope it belongs to and will throw a runtime error when the hosted background service starts. But we can create our own scope when running a background task and resolve a scoped service from that scope. To do that, we need to inject the iService provider instance into the hosted service. Within that interface, we can use the createScope method to create a new scope instance. From there, we can use our new scope instance to resolve a scope service into our background task. Let's take a look at it in action. So we set up our classes for dependency injection. So we've got a singleton service here, we've got a scope service here, and we've got a transient service here. If we go into our program class, we can see that these services have been registered to our DI container. Going back into our hosted service now, what we're going to do for this myBackground service is we're going to create a constructor for it, and we're going to inject the singleton service and also the transient service. Let's give that a run now. Let's check our web application's working. As you can see, our web application's running. Let's stop that now and let's add a scope service into our hosted service. So it's iMyScope service, myScope service, and let's give that a run. You can see here we've got an exception here, and the exception is cannot consume scope service. That's because the hosted service is a singleton service and it's not able to know which scope it belongs to. If we want to use a scope service in a background service, we can explicitly define a scope. If we go back in here, and what we're going to do is we're going to go into our execute async method. But before we do that, we're going to have to pass in the iService provider in here like so. And we need to create a local field for it, so we've got the instance for it. So we're going to go ahead and do that. Give it a name with an underscore at the beginning and assign the instance from the parameter in our constructor. What we can do now is we can go up here and we can use that instance to create a new scope. So it's service provider.createScope. I'm going to add these into our scope, and we're also going to get the instance of our scope service. So we have to call the scope instance the service provider, and what we can do is we can call this method called getRequiredService, and we're going to pass in the scoped service. I'm going to stick a breakpoint now and just make sure that we're going to get an instance. So let's run the application. And as you can see, our hosted service is running, and yes, we've got an instance for our scope service. Should a background service be used in an ASP.NET Core web application? Obviously, it's a good idea if we want to share data to all users of the website. However, we might find that the background service has performance issues which could affect the web application stability. An alternative is to use a worker service template, which is solely a background service. If you see a video above me, please check it out. Otherwise, keep checking youtube.com/roundthecode as we're going to release a video very soon.